Hi, my name is David King with my lab partner Zayar. And today we're going to be talking about TLC, which is a common lab technique that can help you identify what compounds are in a mixture by separating them based on polarity.
So to do a TLC, you need a beaker, a watch glass, filter paper, TLC strip, capillary tubes, the solvent that you're going to use, which is 2,2,3 ethyl acetate to hexane, and the solvent which you're going to dissolve the starting material, p-vanillin, and the product, vanilla alcohol.
So in the chamber, you put a thin layer of the 2,3 ethyl acetate hexane. It should just be enough to cover a little. And then you take the filter paper, you fold it in half like this, and you put it on the side. Now, the 2,3 ethyl acetate hexane mixture is very volatile and will evaporate quickly. So while you do the rest of the procedure, you put a watch glass over it to cover it up. On the TLC strip, with the pencil, draw a line about 1 centimeter from the bottom. Then, to spot our compounds, we'll use a capillary tube. So here I'm going to dip it into the p-vanillin. So I get a little. And I'm going to dip a small amount on the line. It's really important not to get too much. So then I'm also going to do that for the other compound, our dissolved vanilla alcohol. And then we'll let it dry. Once the materials on the TLC strip have dried, we place them in the developing chamber, and then we wait. It's important that the solvent starts below the line so that it doesn't run off. And now we wait for it to develop and run up the TLC strip using capillary action. So now we can see that the solvent is close to the top of the TLC strip. So we'll remove the strip from the developing chamber, and at the solvent line, we will draw a line with the pencil to mark the solvent line. So now that the strip is dried, we can put it in the chamber, and we can see spots where the materials have traveled, and then we'll circle them. So now we can use a number called the RF value, which helps tell us the composition of the compound and its polarity. So RF equals the distance traveled by the compound over the distance traveled by the solvent. So now we'll measure the distance traveled by the solvent. As we can see, it traveled 4.9 centimeters. And we'll measure our first compound, which was p-vanillin, and we'll see that it traveled 2.8 centimeters. Our other compound, which was vanilla alcohol, traveled 2.2 centimeters. To calculate the RF value for p-vanillin, we divide 2.8 divided by 4.9, which gives us an RF value of 0.571. For vanilla alcohol, the RF value is 2.2 centimeters divided by 4.9 centimeters, which gives us an RF value of 0.45. So we see that p-vanillin has a higher RF value than vanilla alcohol. And since the solvent, which was 2,2,3 ethyl acetate to hexane, was nonpolar, we know that p-vanillin is more nonpolar. Therefore, vanilla alcohol is the more polar compound.